All right, welcome everybody to our 16th SLiTHER. So today we're joined by Sabrina Sobel, who's going to talk to us a little bit about scaffolding for open questions, right, and open responses. So I'm going to go ahead and pass the floor over to Sabrina. Thank you.
Hi, for those of you who don't know me, I'm Sabrina Sobel at Hofstra University, and I've been there almost a quarter century. And I have been, the whole time been the only inorganic chemist. So this is the kind of experience that we all have, that we're the solo beings in our department. And one of my standard classes is to teach general chemistry. That's what I taught in the fall, and that's what I'm going to use as my example for scaffolding and leveraging technology in this COVID-19 era. So I'm going to share my screen. Oh, sorry. So my class that I'm going to be talking on, this is a class size of 48 students. And what we do is we make multi-sections that aren't that big. And so they're all taught independently by full-time and adjunct professors. And so my fall 2020 format for my class was a hybrid class where we had 2 weekly 90-minute lecture times, and the students could attend in person or remotely. So I had to manage both attendance styles at the same time. And then we had 1 weekly recitation through Zoom that was an hour long. So it had to be all electronic. There was supposed to be no exchange of papers, and exams must be online. So I couldn't have traditional in-person paper exams. So my challenges were class time construction. How do I teach simultaneously in person and online? How do I ensure student participation? Also in the assessments, online homework, how do I make it relevant and keep students away from gaming the system? And online exams is a big issue of security and relevance. And I actually had a wonderful conversation with my colleague in the department. She and I sat down through Zoom and tried to talk through and reason through ways that we could construct our classes in a meaningful way so that we are assessing students honestly, not letting them get away with cheating only. So I also wanted to create a pathway to success for students, because with general chemistry, you've got freshmen, and freshmen are making that big transition. So I also had that in the back of my head. How do I help students learn effectively in this different format that we all got tossed into? So for us, the class materials are OpenStax Chemistry 2E textbook and Sapling online homework. So those are the things I was working with. So what did I used to do? I used to do what a lot of us used to do. I had online homework, sapling questions, repeat chances of questions with decreasing points so they can use it truly in a homework format. I always had a weekly POGL style group work, and the students handed in one sheet for their group, and they got feedback and points for participation. Exams were traditional paper exams. I usually split them up into 2 sections. One was short answer format and the other was long answer format. And I always gave them a practice exam from previous years for them to study from. So for this new format, no paper. The online homework I can keep. The Zoom class participation, I use breakout rooms in the Zoom for each group during the group work days. When I did that, I found it very effective as long as I had a TA. So I did have an undergraduate TA who worked with me, and he could float among the rooms as well. And I had the students sign up for the rooms in Blackboard, and then I would create those breakout rooms with the same name. And I'm not being particularly creative, like I had alkali metals, alkaline earths, and so on until I had enough rooms. And then those students would always work in that particular breakout room. And what I found out is that they really need to hand in their group work individually so that I can keep track of it on Blackboard, because Blackboard doesn't make it easy in the grade book to do them as groups in a discussion format. It tends to just balloon in columns. So that's something I learned through doing it in last semester. And finally, the exam format that I settled on was 80 points of sapling questions plus 20 points of an oral exam that was administered through Zoom. So this is a completely new experience for me. I know oral exams, that's, goes back to ancient Greece and rhetoric, but for me, totally new. So what I wanted to think about is, how do I disincentivize cheating? I'm also part of a Facebook group, Teaching Chemistry in the Times of COVID. And there was constant constant chatter about how if you have any kind of online homework system, someone else has figured out what the answers are and posted them somewhere. And of course, you're going to think about the real notorious ones, Chegg and Course Hero and all of those. And even organic chemists who created new questions and posted them for an exam, within 15 minutes of the exam being up and live, they would find answers on Chegg or Course Hero. So this idea that you can't get away from the cheating, you have to, I took a different attitude towards it. My attitude was, okay, I cannot stop cheating, but I can disincentivize it and put everyone closer to being on a level playing field. And so what I did was I provided a database of all the possible questions from the homework that could be on the exam. And I let those students practice those questions to their heart's content before the exam day. And then it was closed on exam day. And then I chose 40 out of those practice questions. And so it was somewhat randomized because I pooled them by topic. So it's like 2 out of 5, that kind of thing. And I only restricted it to 60 to 90 minutes. For the first exam, I restricted it to 60 minutes and the students, were up in arms. It wasn't enough time. And it showed on their grades. Their grades were closer to what it would be if this was an ACS standardized exam. So for the subsequent exams, I lengthened it to 90 minutes, but it was still 40 questions. And they did fairly well, but there was, a spread of grades. So I could tell just giving them the time pressure reduced their immediate desire to cheat, and also having a chance to look at the questions ahead of time. If they want to write down all the answers of all 100 or 120 questions that I put up for practice, more power to them. They'll learn just by writing down those answers and then trying to figure out which one to use at what time. And, some of them were algorithmic as well, so you don't always get the same numbers. So I figured that was a good way for me to use Sapling in an intelligent fashion. Now, the oral exam was really where I wanted to get a genuine sense of what the students understand and don't understand, because you can't hide in an oral exam. So I wanted to focus on some key concepts and problem-solving techniques that they really needed to have some understanding of, such that they emerge from the class pedagogically learning what they should. And the other incentive, if you want to put it in a little pithy statement, is they should not be able to achieve an A grade in a class through cheating. Just no. The best you can do is maybe a B. So my original thought was I was going to choose one of my traditional exam long answer questions, create multiple versions, and hold 15-minute Zoom meetings for each student. So, before we get to that. Now, this is a substantial time commitment. I had 48 students in my class. So 48 students, it comes out to about 8.5 hours that I devote to these. And the way I rationalize it is that I would spend at least that amount of time, maybe more, hand grading all of their exams. So instead of spending the time grading their exams, I'm spending the time with individual students assessing their ability to do part of the work that they need to prove that they've learned the chemistry. So that's the way I looked at it. I looked at it, as a swap, even though it is a big time commitment. And I developed a way for my TA to participate in the Zoom evaluations in a fair and reasonable manner. So first exam, what did I do? I chose 2 of the standard questions that they had as practice questions. They had it in the group work. We did it in class, but I didn't focus on, this is going to be one of your oral exam questions. For first exam, I said it's just going to be one of them. So I had 2 fairly quick questions on the first oral exam that they can get done in 15 minutes if they know what they're doing. So the first was an isotope abundance question. The way I created new numbers for it was just saying, okay, this is an artificial mixture. Because once you have an artificial mixture, you can make it whatever you damn well like. And so I chose 6 and 7 lithium, 10 and 11 boron, and 35 and 37 chlorine, and I just made them up. Now, and then I randomized who got what, and that was the first question. And then for the second question, it was a percent composition. And I made sure that I had something that had carbon, hydrogen, and one other element, nitrogen, oxygen, or it could have oxygen as well, and maybe sulfur. So I did have one with sulfur, and that was, MF2. So for this one, it's just, standard calculate where your empirical and molecular formulae are based on the information that you have. And so I made up 7 of those. So if you consider, if you randomize 2 questions across those 48 students, you can come up with a much smaller proportion of them having exactly both questions repeat from student to student. So even if they talk to each other, the most they can talk to each other is, this is how you solve it. So they actually learn the solution method to prove it to me. So that's what I did with that. And so how did I administer this? This was a bit of a learning curve again. So first I had students sign up through a Google Sheet, and I found that students would rewrite other student names to add news. And so instead I set up Calendly, and they could sign up for 15-minute slots. You could also do it through Doodle, I guess. And so once they sign up for a 15-minute slot, someone else can't rewrite their name over it. And then I opened the Zoom room at the beginning of the session. So I'd have a Friday afternoon session, a Friday evening session, a Saturday afternoon session, a Saturday evening session, a Sunday afternoon session, and a Sunday evening session, and I was done. And I put out more slots than I needed. That's the other thing, is that I sort of built in random break periods for me. And so what I'd do is I'd open the Zoom room, they'd be able to enter the Zoom room, and then I would bring the student whose 15-minute time slot it was, I'd bring that student into a breakout room. I would display the question on my screen. She or he or they would have to put their camera on so I can see what they're doing the whole time. And then I start my timer, and I encourage them to tell me what they're doing while they're doing it. And I found that some students were amenable to that method and some students were not. Some students preferred to just work it out and then walk me through it after. And I would take real-time notes, and I'd also complete a rubric report, and I'll show you that rubric right then. And then the student submits their worksheet via Blackboard within an hour of getting this all done. So it allows them a little time if they have technical issues. So the rubric was really important because that was a way that I could standardize the assessment with me and my TA across all of these students. And so I had a very general assessment rubric, and since it's general chemistry, it's a lot of problem solving. That's what I focused on. And so you can see the items on my rubric are pretty standard, and it just had a three-point scale. And I shared this rubric with the students so that they knew what was expected of them. So I was scaffolding what they needed to know ahead of time. This is what you have to make sure that you cover when you solve these problems. You have to identify it, you have to choose the correct equations, be it a chemical equation or mathematical equation, provide a logical solution process, identify your variables, use your supplementary information, complete the calculation, and ascribe correct meaning to your numbers. So just very general but useful. And between me and my TA and writing notes on the assessment rubric, so I just had this big Google sheet doc. So each tab was another student. And so my TA, he had one with the tabs of the students that he did. And he did about a third of the students, and I did about 2/3 of them. And I could take his rating, and I could then look at the student work and his rating and assign a grade. So that was exam 1. So exam 1 was the grand experiment. And I had to listen to the student feedback because I wanted to make it better. So the students said the questions are reasonable, but they really wanted to be able to practice question type before the oral exam. Okay, so they really need some explicit scaffolding. I did some sort of implicit scaffolding, like the questions were familiar to them, but they didn't know this was exactly what they would get. And so the changes I made was I modeled the problem type in class. So I really had to plan ahead what I was going to focus on for the oral exam. I assigned one example as a group work exercise, and I made it explicit. I told them, this is the model of what you're going to have on the oral exam. And again, I made up multiple types. So multiple individual questions based on the type, like I had in the other one as well. And I also had to use the time wisely, so that I was really testing them on some really key stuff. That's the other thing, is you have to identify what you think is just most important and just focus on that on the oral exam. Let everything else be tested in some other way. So you saw what I did for exam 1. I had 2 questions, which are pretty standard exam 1 topics for general chemistry. For exam 2, what I did was I had them balance a chemical equation and then complete a limiting agent problem about that chemical reaction. So I had that on 2 parts, and I explicitly told them what to do. Balance the chemical equation here. Now with that balanced chemical equation, find, percent yield if such and such of this product was obtained, that kind of thing. I made very, very explicit statements. For exam 3, I had them balance a molecular gas reaction, draw the Lewis dot structure of the molecules, and calculate the enthalpy of reaction from the bond energies. So it was, it was a stepwise walking them through getting to the final answer. And then for the final exam, I made it 30 minutes. So it was twice the amount of time of the individual exam, oral exams from exams, regular hour exams. And so for the final exam, again, it was a process to get to understanding a particular topic. So the first thing is using density and percent composition, calculate the molar mass and determine the molecular formula of an unknown gas. Then you have to draw the Lewis dot structure of the unknown gas. Then you have to predict the final pressure of carbon dioxide formed from the combustion of a certain amount of, this is from one of the examples, grams of the unknown in excess oxygen. So I had to make sure that all of my unknown gases had carbon in them. If they didn't, I would have some other product that was a gaseous product. And they had to balance the equation of combustion. So you can see how I have scaffolded what they need to learn. And then the grand sum is sort of in that final exam, oral exam process. And I found very quickly that students who really didn't know what they want and didn't know what to do, they just didn't have that knowledge. They found out it was a very visceral experience for them not to do well on their exam 1 oral exam. Some of them recovered from that. Others just decided, okay, I'm moving on. I'm going to take our preparatory class and then try this class again. But I found that in general, the attrition in my class occurred quickly earlier in the semester, which means they could transfer into another class very easily, such as our preparatory chem class, or just leave chem off for the semester and go to another half semester class. And then my attrition overall was reduced, which I was really pleased with. So the lessons that I learned by doing this is that I really got to know the students better. What I found is that when students are a sea of masks and eyes, I can't tell one student from the other. It's very difficult for me. When I had these individual 15-minute sessions, I got to listen to them. And I got to know them as an individual student struggling with the topic. And it also encouraged soft skills development for the students, because you get interviewed for jobs and you have to give your oral defense. And so this is a situation where you have to show your knowledge and be able to speak about it intelligently. And I found that from the student feedback and my expectations, I created better scaffolding of their learning and performance. And so I was creating a new pathway to success that was leveraging the technology that I had. How else can I have 15-minute appointments with students at 7:30 at night? That's because I'm sitting at my desk at home and it's easy. And I could still engage in meaningful assessment. And for me, it was very meaningful because I learned a lot about how they learn. And I also found that I could also start to see and help address non-academic issues. Like some students had a hard time getting the technology to work. One student had to sit outside for the first oral exam because that was the best internet connection. And others had family intruding on them, and I had to, sort of help them establish a safe zone so that they could focus for those 15 minutes with me. And then I also, I have notes that, you know, if you want to ask me about, I have notes about, you know, how do students think and how do they think through these problems and what were the different solution styles I found, which was just fascinating for me because I'm usually on my teacher side and I just see the stuff on the paper. So that was my experience. So I'm really open to more discussion. This was just to give you a sense of what's going on. So I'm going to stop share. And there's a bunch of comments. The grand experiment. I know, that's what it was.
I think there's a lot of impromptu grand experiments over the past year. So it's like, oh, well, I'm doing this. I might as well try something different. So let's go ahead and open up the floor. So if we have any kind of questions or things to throw out, we could start a discussion on kind of scaffolding and thinking about how we can approach this new assessment in this new world that we're living in. Yeah, go ahead, Kyle.
Yes, thanks, Sabrina. That was awesome. I really like that you went for oral. You know, and that's something I've been thinking about doing, but kind of scared of. And that was one other thing I was curious of is when students were doing the oral work, how much did you have like like prompts or something you could give them that was like help where you could tell they were struggling, but like point them in the right direction? Did you do any of that, or did you like just step back and say do it?
Sometimes the best way to get them back on track is to ask them to go back and carefully read the question. And sometimes if you have them carefully read the question or read the question out loud to you, they start to, oh,
yeah.
So I've even had smart students who were so nervous that they zoomed through the question, they missed something critical, and I had to get them to go back and read the question again. And then it was light bulb, oh, that's what I missed. So I tried to be Socratic and never give them a prompt that gave them some information that they shouldn't have. And so that was important for me, keeping my contemporaneous notes because I could see where they went wrong. And I even had one student who was so cute because I post my notes afterwards in my assessment. He said, but you wrote down exactly what I did. Why did I get a 5? I said, because what you wrote down was so wrong. Yeah. Just because I wrote it down for myself doesn't mean that I wrote down what was right.
Yeah, you were just recording what they did, right?
So that's the thing. That's the big thing is you have to sit back and you have to be perfectly calm and encouraging, but not offering anything.
Yeah.
And that was the hardest lesson for my TA. My TA was like, but I want to help them.
Yeah, it's a summative assessment. You gotta, yeah, because I was thinking about doing it for inorganic.
Oh, I'm doing it this semester. I loved it so much. I'm doing it again.
Yeah, I did a similar kind of thing. Did you do any open-ended questions that were not math? I didn't read all the ones that you posted. You know, a lot of the ones that I looked at were numerical kind of questions.
Right. So these had to be numerical because it was general chemistry, and that's really what you got to focus on. The only thing that was non-numerical was Lewis dot structures and balancing chemical equations of reaction. With my inorganic group, I think I'm going to ask more evaluative questions, but I'm also going to be very explicit in the wording of the questions so they know what I mean. That was one of the big things for me was that I was really missing the fact that how I wrote things could get students hung up on what I consider irrelevant details. But because they don't have the experience to be able to judge, they become hung up on these little bits. And so that's by scaffolding it and showing them exactly that question type. So you got to choose a question type in which you can generate a database of possibilities, but showing them exactly that question type so they can ask questions about how that question is worded and learn what I want. That was really, really important for their success.
Yeah, I always feel like I have that inner turmoil where I'm like, am I hinting at too much where I'm telling you? But the truth of the matter is, if they memorize the process, then essentially they've learned how to do it. It's, you know what I mean? So it's one of those catch-22s almost. So
exactly. It's if they prefer to crib the process, they still have to show you in the moment how they're using it.
Yeah, I had a question or a comment or idea. I don't know. It was kind of floating around. So you were saying you had 3 exams and a final, right? So that's kind of 4 opportunities for these oral assessments. And you said one of the bits of feedback you got was that students really wanted kind of more preparation or more kind of guidance leading into these. And I think that scaffolding is a really interesting way to kind of approach that, because I think on the first one, it makes a lot of sense to like give them a lot of like structure and organization, and this is what to expect. But I think that over time that could fade away, right? So like you give them a whole lot of guidance early on, and then the next time you give them a little bit less prep on what's going to happen. And hopefully by the end, they're like, oh, this is maybe the kind of question that she might be asking for this, or, you know, how can I approach this? Because I think that that's an interesting way to kind of slowly fade that out, right? With 4 opportunities, right? How might you envision that you could change kind of your approach over the course of the quarter to see the growth in kind of this oral exam?
I think I don't have to prompt them as much. I don't have to say, look, the question we're doing in class is exactly the question you're going to get on group work and then on the oral exam. I did that explicitly for exam 2, and past that point, I just said, this week, the group work we're doing will be the model for the oral exam. And because they had gone through it before, they would know that what they needed to do and what they needed to attend to. So I did some pullback, but not a lot, because these are freshmen. It's first semester.
Yeah, the other thing that popped up, and I can't believe that I'm suggesting this is an interesting idea, but I like that idea of having multiple kind of randomized sets of questions, right, to give each student an individual experience. And back when I took the GRE, one of the worst things in the world was the fact that it was an adaptive test, right? So it got harder the better I was doing. But you get a much better like striation of your population with fewer questions. So have you ever thought about that, where like the second question is based on how well they did on the first question, right? So maybe they get a harder question that's worth more points if they really nail the first question. But if you beat them up on the easy question, you can't follow up with a hard one.
Well, there's 2 parts to that. 15 minutes, you might think, oh, wow, that's a long time. No. So you really have to keep the format the same. So I wouldn't do that. And I think the other thing is that the one problem with adaptive exams is that every person leaves feeling stupid. And that's fine for, an assessment exam that is outside of a class. But what I don't want to do is I don't want to have the students leave my class feeling stupid. So
when I did my oral exams, I did something kind of similar. I said, all right, I got a bank of questions here. And I just said, if I tell me a number and a letter, right? And then I jot down what number and letter. There were 3 PowerPoints that I would grab one of them at random. But at least got to that idea that, oh, there's a whole bunch of different questions, right? I can't really cheat with somebody else. So that was kind of a fun little. But I only got to do that one exam, and that was at the end. That was last spring when I did the oral exams, because we had to go completely remote. Last semester and this semester, we're able to meet somewhat in person. So we've been able to do exams in person. So.
Oh, that's great. Yeah, we were banned from exchanging paper. You can imagine what it does to teaching lab. Everything had to be scanned and uploaded.
Did you notice, or in the feedback, did you have any comments about nerves?
So I informally asked some students about it. I'm going to do a formal Qualtrics survey, because I want to drill deep into their experience. So I could tell when students were nervous, so I would try to, say, take a deep breath and then let's move forward. Let's read the question together, something like that. And so, because I wanted to make sure that even if they felt blocked in the moment, I could move them past that block and they could start to feel more comfortable and do it. And I think scaffolding helped a lot to reduce the nerves. From exam 1 to exam 2, the level of nervousness was greatly reduced because they knew what was expected of them. And I still had students who made mistakes all over the place. So it didn't stop the mistakes from happening. And that was my concern. I didn't want them all to get it perfect. It was like a useless assessment. So one thing I noted was there were different solution styles, and I thought this was super cool because, it's hard to tell when someone just writes something down, whether they're using a different, solution style. And so I would find that there are different paths to the same answer. And some of them were paths that I didn't teach. And since it's general chemistry, I'm wondering if it was paths that they learned in their previous chemistry classes that they were now applying to this class, which I thought was really cool. And it caused me to step back and think about, what is the logic in this question, and see the logic from a more holistic perspective rather than just my particular path that I like to take to the answer. I found that, I expected students to improve in what they're doing. Like I gave them 2 chances at limiting agent problems. I gave them 2 chances at Lewis-dot structures, that kind of thing. But I still noted that some students were still having trouble with Lewis-dot structures even at the final exam, after they had the oral exam that really focused on it before. And so it makes me a little bit upset because I want everyone to do well, but it shows that, learning doesn't always occur in the time period that we give it in the class. And that was one thing. Let's see, what other things? Reality. My reality checks. Absolutely have camera on in Zoom. You need 5 to 10 pre-solved versions of the oral exam question. You have to a convenient and secure way to let students sign up for the oral exam appointments. That was my problem before. And then students need to be trained on oral exam expectations and behavior. And so it's really, something that you might want to, because I just tossed them into it. I was like, okay, we're doing it. And, this time around, I think I want to post a list of, do's and don'ts, about, what do you do when you're in this situation, so that you're being a good citizen during the oral exam.
Anthony, did you have a question?
Yeah. Thanks, Taylor. So that's I was fascinated by what you did, Sabrina, and I'm a bit jealous because I would love to do something like that in my Gen Chem, but I have 100+ students this term, and I only have me. I have no TAs. I have no anything. Just the one thought that I had, which I would like to get a flavor of this, is in the past that at Merrimack, all of our students have iPads and Apple Pencils. So I know exactly what technology they have access to, and so what I tried in my inorganic class in the fall was, it was the end of the fall semester. Everyone was like spent and done. And my students were like, I can't do a final exam. Like they were done. So I actually let them choose 3 topics from the terms. What was I gave them a list, and then so each of my 8 students got to choose 3 topics. Then I made an exam, 5 questions for each student, and then I gave it to them, and they made a 15-minute video of themselves orally answering the questions. And then they submitted it back to me, because I asked them, I said, you could either do it on Zoom to me face to face, right? Like orally, or you can make a video and submit it asynchronously. And my students were all like, asynchronous all the way, because they were so stressed out by the prospect of them sitting across from me, of course, virtually, right? And trying to answer these questions. They liked the asynchronous model, and it was a small enough class that I could get those varied questions, because I had 5 totally separate exams, right? Because I had 8 totally separate exams, because I had one student who really liked solid state chemistry. So it was 5 questions on solid state, but it, we talked about bonding and structure and all of that. Whereas one kid who wanted all bio inorganic, so it was totally separate, right? But I could do it for that class. And I'm just sitting here churning sort of how can I adapt sort of that and sort of meld it with your idea from my larger course that I have 103 this semester all by myself. And so I'm just here and I'm churning, saying like, how can I make something like this work, right? And so I really liked everything that you said, and especially about the scaffolding, because you're 1000% correct that scaffolding is the most important thing. Because if you don't do that, oh my God, like what happens? You can't think of the ways that things can possibly go awry, right? So.
So what I would recommend to you, I would recommend that you recruit older students who have been through your class already and let them be volunteer TAs. Because if you have a consistent rubric that you like, that handles the parts of the solution process that you want to really assess, you can have all of them fill out that rubric, take a contemporaneous note. So you have to train them ahead of time. So that's what I'm doing this time. I'm training my students for the inorganic class ahead of time. So that, and when they volunteer to do this, they learn the topic better. So let's say they're pre-meds and they want to do better on their MCATs. They'll know their Gen Chem better because they spent the semester. They will be helping students who are, coming up behind them. So they have that, virtuousness that you're tying into this. And it's a minimal commitment for them, because all they have to do is say, okay, for these times, I'm going to handle a certain number of these students' oral exams. Plus, you record it through Zoom, so you can always go back and look at the recording and make your own assessment as well. But that way, you keep the undergraduates out of the sticky situation of trying to assign a grade. They shouldn't be doing that anyway. But you're recruiting undergraduates to help you with that time burden to get this done. And once you have the contemporaneous notes and you have that rubric assessment and you have the student work, you have 3 things to look at. You can make a grade on that 5 minutes. I spent more time just photographing my sheets than anything else.
Well, that's actually a really great idea, because we have student tutors in our department who tutor, and then I might be able to go and leverage those students, a couple times a semester. So that's a great idea, Sabrina. Thanks.
Yeah, because I'm also in a situation where I only have undergraduates, so I never have graduate TAs help.
No.
Any other
So
questions?
earlier, there's another question. I think earlier someone asked about evaluations. I was curious if this popped up at all in like course evaluations, or like what the student perspective was at the end of a term after experiencing kind of these 4 events.
I will know at the end of this semester when I get back the buff sheets with their comments on them. And that's also why I'm going to do the survey, so I can drill more into their perceptions of the process. Because I set it up at the beginning of the semester. It was explicitly on the syllabus, and here we go.
And maybe that was why part of my problem is that, it was last spring when it was just a crapshoot, and I kind of sprung it on my students. I said, also, to make sure you're not cheating, we're going to have an oral part of the exam, and that probably wasn't fair in hindsight. I don't think luckily I had 2 exams before we went remote, so I had a pretty in the back of my mind, I said nobody's going to get a lower grade than they had at that point. Unless they just didn't do anything, you know what I mean? But I was like, if you're getting an A, and this was a non-majors class, so I was like, if you're getting an A through, the first start of stoichiometry, I can assume that you would have, and I had no idea how my teaching style was going to go as well. So it's really interesting that you're putting this into a class that's a little bit more normal, right? That's kind of the fun part, is that you're doing a little bit of the oh crap kind of, how am I going to get this to work, into like a fairly, to call this a normal semester is weird, but
yeah. But I think that now that we've been tossed into technology, kicking and screaming, I don't think we'll ever retreat from it completely. I think that I think at my institution, we're always going to have the remote only option for some students. And it might be just that, oh, I'm sick this week, I'll just listen in, or I expect you to always record your lectures so I can look at them later. But I think we're never going to be away from this technology anymore. So why not go back to what the ancient Greeks said was so great and leverage it for now?
I have an off-topic thing. If anybody else has just something that you were talking about in the process and hearing about that resonated with me today, because I actually gave my advanced inorganic test today, and when we were going through some examples in class, we were talking about Lewis structures and placement of ligands based on electronics and sterics. And one of the students was like, well, how do you grade something like this? Right? Because I said there at one point you get to a point where there's so many different arguments that there's no real reason why an undergraduate would know. And she's like, how do you grade this? And I was thinking, I had a very weird, like, being a person in front of my students. Usually I try to keep up this front. I said, if you would have asked me that question, 4 years ago, I probably would have said it's more important to get the right answer, right? And I said, as professors, our ideas, our hopes are what we're trying to get you to do, and how we want you to learn changes as we grow in our profession. And it's just this weird, like, yeah, I guess if you get the wrong, and what I told her is that now where I am, I would say, if you get the wrong answer, but you have great justification and rationale, you could get 7 out of 8 on a question. But if you get the right answer with poor explanation, you might get a 4 out of 8, right? Like, and it was just kind of a weird, and that's why getting to like what you were saying with the more types of questions and giving different types of hearing how they walk through it. Because it doesn't always end up on the paper. And,
right.
And the interesting thing when I did is that, and you probably had this thing too, it's nobody left that answer blank in the oral exam, right? There was no 5 minutes of nothing like there would be on a test.
Yeah.
And so I think that says something to, at least to my students. I thought that was an interesting showing, I guess, because I usually would have 1 or 2 questions. Hey, there's nothing on there. Easy to grade, but not good for their test.
Yeah, I think also you can find out the holes in your presentation that you were blind to, that are holes for the student seeing it for the first time, because you see again and again, oh, they're making the same mistake. They're making the same mistake. Oh, wait a minute. And some, on math problems, usually can see that because you can see where they go wrong. But when it's a reasoning question, like, why did they get this Lewis dot structure wrong? It's easier to figure out how that happened by listening to them as they're going through the process.
Absolutely.
All right, any last questions for Sabrina? All right, well, thank you very much, Sabrina, for sharing and walking us through this discussion today. So our next SLiTHER is coming up on March 4th. So keep an eye out on the normal kind of channels for that, for the registration. We're gonna be joined by Dan Kissel and Carrie Stone. We're gonna be talking about teaching general chemistry online. And with that, thank you very much. I'm gonna go ahead and stop the recording and again, say thank you for presenting and thanks for coming, everybody.